stem and leaf graph is just a simple graph which is part of the exploratory data analysis in statistics. It is good for small data sets because we write stems in a vertical line starting from smallest to largest in increasing order, and then we draw a vertical line in front of the stem and then or to the right of the stem, and then we write the leaves in front of each stem. So there could be many leaves for one stem and we write them horizontally. For example, the number 23 has stem 2 and leaf 3. So the last digit, the number ending with, is the leaf. Similarly, the number 432 has stem 43 and leaf 2, and the number 5432 has stem 543, while the leaf is the last number, which is 2. And similarly for decimal numbers like 9.3, 9 will be the stem and 3 will be the leaf. Now please look at the data set here, and you can see that there are student scores for the first exam, of which the first number is 33, which means the both of the stem and leaf are 3. Then there's number 42, 49, 49. All of these three numbers have the same stem, which is 4, and 3 leaves, 2, 9, and 9. 2 comes from 42 and 9 comes from 49. So we write 4 in the stem column, and then we write 2, 9, 9 horizontally in front of 4 to show that there are 3 scores starting with 4. Now can you please write all the scores starting with 5? Please pause the video here and do the job. Okay, now we see that there are 7 scores starting with 6, from 61 to 69. So we take the stem as 6 and write all the leaves. Please verify that they are correct. And then there are 4 scores for 7. Now can you write the scores for 8? Please pause the video. Okay, and then there are scores for 9 and 10. Now you can see that for the leaf, for the stem represented by the number 10, the leaf is 0. It doesn't mean that it doesn't have a score. It shows that it has the 100% score, 100 score. So 10 is the stem and 0 is the leaf. So there is a score. Okay. Now from this data set, can you tell me where has the student got most of their scores? And for that we have to look at all the stems that have the longest line of leaves. And you can see that 6 and 9 have the longest line of leaves. So most of the scores are in 60s and 90s. Now the second question is, how many of scores were in the 90s or 100s? So we have to include all the scores in 90s or in 100s. So altogether there are 8 scores. And how many are the total scores? You can count from here that there are 31 scores. So if 8 out of 31 are in 90s or 100s, then this counts 26% of the scores. And the third question is if the student got a fairly high number of A's, and you can see that yes, if 8 out of 31 scores are in 90s or 100s, then the student has fairly high number of A's. The first example is of the Park City basketball team, and we are talking about their scores for the last 30 games, and they are given in order. As you can see, that is starting from 32 and ending on 61. So they are written in ascending order. So it is easy to see what numbers can stand as stems. So the first number is 32, and we know that in 32, 3 is the stem, 2 is the leaf. So in the first option given below, where we have to identify if it's the right option and the right stem leaf graph, we see that they have used 3 as leaf and 2 is they have used 3 as stem and 2 is the leaf. And now if 3 is the stem, then we look at all the numbers that have 3 as stem. So that is 32, 32, 33, 35, 38. And 3 is the stem up there, and the leaves are the numbers on the right hand side. So 2, 2, 3, 5, 8, and we see that 2, 3, 5, 8 are the numbers given as leaves with the stem 3. Do you think it's the right choice if this choice of 3 only taking a stem can be considered? Obviously no, because 2 is coming twice as a leaf, and there they have mentioned 2 only once for the stem 3. So we leave this choice and we move ahead. Okay, in this one the stem 3 has leaves 2, 2, 3, 5, 8, which is correct. Now we look at all the leaves of 4. So they are starting from 0 going up to 9. 3 is coming twice, 7 coming twice, and 8 is coming 3 times, and we need to verify that from the data. So please look at the data carefully, and all the numbers that start from 4, because 4 is the stem in this case. So we see that 3 is coming twice, 7 is coming twice, 8 is coming 3 times, and all of the numbers are not difficult to count. Now for the number 5, we have 0 coming twice, 1 is once, 2 coming 3 times, 3, 4, 6 and 7 are 3, 4 and 6 are coming once, and 7 is coming twice. So we check that in this option, the second option. With the 5, 0 is coming twice, 1 is once, 2 3 times, 3 once, 4 once, 6 once, and 7 2 times. So this also seems to be correct. And if we look at the stem 6, then there are only 2 numbers, 60 and 61. So the second choice seems to be the right choice. Now if we've chosen the right choice already, we don't need to go further, but let's look at the other options to see why they could not be the right options. Now in the third option, you see that again not only 2 is not coming twice as a leaf of 3, but the order is not right of the leaves, because the leaves should be written from the smallest to the greatest number, which is not the case here. And we can see other problems in other stems. So there's no repetition of leaves with stems 4 and 5 as well, and again the order is missing. In the last choice, probably it is very clear to see that the order is missing, even if the repetitions are there. And sorry, this was the second last choice. The last choice is even worse. So because the stem is coming in the stem column, but then stem is coming again in the leaf column, which is not permitted. So we don't need to write 32 here in leaf, because 3 is the stem, not the leaf. So 3 should only be written in the stem column, while 2 can only be written in the leaf column. So these are the problems in which these could not be the right choices, and the only correct choice is the one we chose, and we can always check if we have chosen the correct choice, and this is correct. In the second example, we look at the scores that represent distances in kilometers from home to a local supermarket. Okay, now if we look at the scores, most of them lie within the range from 1.1 to 6.7 if you look at the smallest and the largest score. However, there is one score, 12.3, which is too far from the given range. So we can assume that this is an outlier, and this has come by mistake or by an accident from somewhere else, because most of the scores are within 1.1 and 6.7. So we don't worry about the last score. However, when we create the stem and leaf graph, we enter all the stems, and which are to the left of the decimal. If we recall from the lesson, all the decimal numbers have their stems to the left of the decimal and their leaves to the right of the decimal. So this is how the stem and leaf graph would look like. Please take a minute to understand and check and verify that each stem has the right number of leaves from the score. This is a little exercise for you to study the data that describes the distances in miles from the homes of some students that live off campus and they study statistics. You'll have to identify the right stem plot for the data that is provided. Now, the first step, as you know, is to look at the data, grasp it, and look at the minimum and the maximum numbers. Please do that now. Okay, since the data is in order, you can easily see that the minimum number is 0.4 and the maximum number is 8.0. So we have to create a stem starting from 0 through to the number 8, which are the left of the decimal point. So we know that the stems are always to the left of the decimal point. So we start with 0 and go through to the point 8 to create the stem. And now we look at the right hand side column, which represents the leaves. And my question is the information about leaves entered in the right order? I'm sure your answer is no, because this leaf section must not contain the stem. So 0.4 is the whole is the full number, in which 0 is the stem and 4 is the leaf. Now 0 has already been entered as a stem, so we don't need to enter 0, we only need 4 as the leaf. Similarly, in 0.7, 0 has already been entered in stem, so we only need to enter 7 here. So this representation of stem and leaf graph of the data is definitely wrong. So we move on to the next option. Okay, now in the next option, we see that the stems are written correctly, and the first leaf is written as 7 and 4. Just look at the leaf corresponding to the stem 0. It's written as 7 and 4. Now obviously there is no stem, so it is in the correct format, but is it in the correct order? Obviously not, because the order should be ascending. So 4 should be on the left and 7 should be on the right. So we leave this option too. Okay, now we look at the next option, in which the 0 stem has leaves 4 and 7, which is correct, and the stem 1 has also its leaves in correct order, stem 2 as well, 3, 4, 5, they are all written in the correct order. Now I'll leave it to you to check if all the entries have been covered in the leaves. Please do that now. Okay, so you might have noticed that this is the correct information and the right form of the stem and leaf graph, and is in correct order as well. So this should be our answer. Okay, once we identify the correct answer, we don't need to go ahead, as there is only one correct answer. So we don't need to go ahead to satisfy all other requirements. This is the answer. So we have to answer one more question here. We have to enter the number of outliers in this column, and if there are no outliers, we can enter NA as not applicable. Now there is also some information here for you to see that you can enter numbers separated by semicolons, and this is if there are multiple outliers. But from the data we see here in the plot, and the correct plot that we have identified, we see that most of the numbers stay within the range of 0 to 5. So there was only one information related to the stem 8. So it could have been either false or just not enough to be included in the main area, and is not really not an information that is suitable to analyze the data from stem and leaf plot, and we can consider this as an outlier. So there is one outlier, which is 8. Okay, now we check if we did it correctly. Okay, so it looks like both of our answers are correct because they are turned green. Next, we look at a side-by-side plot within the stem and leaf plot set, which allows two types of data sets entered for the same stem, and by adding just another column regarding the information given in the stem. This means that the central column, which is the narrow column, represents stems, and on both sides of the stem are two columns representing some information about the same stem. Okay, to understand this, we look at this example. So this table in front of you represents some stems starting from 4 ending to 9, and some information about these stems on the left and the right hand side. The left hand column represents ages at inauguration, and the right hand side represents ages at death. So this information is about some people and their ages at the time of their inauguration and at the time of their death, regardless of who they were, what were their names, and all other information. It only gives information about the age of inauguration and the age of death. So we move ahead and see who are those people whose information is here. And these people are the presidents of the United States. Now the first table, table 2.3, shows you their ages at the time of inauguration, and you see different presidents with different ages. Now our job here to understand the above stem and leaf graph is to find the minimum age in this column, no matter who the president was. We have to find the minimum age. So please have a look, scan this information with me, and note down the minimum age. Okay, now if you are with me, I see that the minimum age given is 42. This is the minimum age. Okay, so we note this number and move down and look at the next information table, which is 2.4, about the ages of the presidents at the time of their deaths. Please scan through and find the minimum number. From the information, I can see the minimum number turns out to be 46. And if we come down to the graph, we can further see if there is any number greater than 46. And we see that all the numbers are bigger than 46. So this means that 46 is the minimum age of death and 42 is the minimum age of inauguration. Both of these numbers have 4 as the stem and 2 and 6 as their leaves. So we enter 4 here in the column of stem, the central column, and 2 goes in the column of ages at inauguration, and 6 goes in the column of ages at death. Are you with me? So this is the information we have entered from what we searched. So starting from the stem, 42 was the minimum age at inauguration according to the left column, and 46 was the minimum age at death. Similarly, we can look at the maximum age of inauguration and the maximum age of death. Now we can see that the maximum age at inauguration was in 69 from the column. There's nobody among the presidents who was in 70s or 80s or 90s at the age of their inauguration. Okay, and the ages of death go up to stem 9, and we see that the maximum age of death is 93. We verify this information from the age of death column. So we see that there were two presidents, Ford and Reagan, who were aged 93 when they died. Now I leave it to you to find the other information correct. So please verify the rest of the information in this column before you come to the conclusion that this is a correct information. Now, what was the purpose of this example was to understand that a stem and leaf graph could be of an advanced form in which the stem can provide information about two entities, one at the right and one at the left. In this case, we are talking about the ages of US presidents at the time of their inauguration and at the time of their deaths. In the left column, we look at all the leaves associated with the stems, which is in the narrow column in the middle. So this gives us information that the minimum age of the presidents at the time of inauguration was 42 and the maximum age was 69. Similarly, the minimum age of at the time of death of a US president was 46 and the maximum age was 93. So this gives us information about only the ages at inauguration and the ages of death of US presidents. There is another exercise for you to identify the correct stem and leaf graph of the data provided to you in this table. Now this table is about the wins and losses of a team for a game played in 42 seasons, starting from 1968 and ending to 2010. Okay. Now in this period, they had various wins and losses which are given in two tables. So for example, the games played in 1968 to 1969 had 34 losses and 48 wins. Similarly, the games played between 1993 and 1994 had 25 losses and 57 wins. Now, without getting the information about which team had the maximum or minimum losses, we are interested to form a stem and leaf plot of the maximum and minimum wins and losses, no matter who was associated with that. So we all are looking at the numbers of losses and wins. So we have to find out the minimum losses and minimum wins and the maximum losses and maximum wins. So if we look at this table, then we have to find the minimum and maximum numbers in the columns of wins and losses. So please go through this table with me. And I see that the minimum number, for example, in these columns, the minimum number is 13, which are the wins, and the minimum number of losses is 19. Okay, is there any number bigger than 13 or 19 or in between them? I don't think so. So the minimum number of losses were 19 and the minimum number of wins were 13. They both have number 1 as a common number. They both start from number 1. So 1 is the stem. So we have to choose the option in which the minimum stem is 1. So first option is definitely not an option because it starts from 0. The second option again starts from 0 is not an option. Okay, so the third option starting from 1. The fourth option is also starting from 1 and has both of these have 9 on the left and 3 on the right, which means there were 19 losses and 13 wins. Okay, now in the last column you can see that the format of the plot is not right, because 1 is stem in the first case and it has already entered as a stem. We don't need to write 1 in the losses and wins. We only need to write the leaf, which is 9 in losses and wins and 3 in wins. So this first example of the minimum number of losses and wins, which was 19 and 13, clearly shows us that this last graph is also not an option, and the option lies only between the third and the fourth graph. Now in the third graph, we see that the information looks correct because all the numbers are written in ascending order. In the wins column, we have to look from left to right for the ascending order, and from the losses column we have to look from right to left, because this is how the leaves are expanding on both sides. And in the fourth column, the only difference from the third one is that in fourth column there are some repetitions which are not there in the third. Okay, so in the fourth option there are repetitions, so we have to check only one of the stem if it has repeated values, and the minimum number I can choose is 2 in the stems, which shows me repeated values in the losses with the leaves as 5. So there should be two numbers representing 25, which means that the loss of 25 must have occurred twice. So let's go back to the information and see if 25 has been obtained twice as losses. Okay, I can see 25 here, and if I come down, then I see 25 in the wins but not in the losses. Am I right here? No, that is in the losses. Yes, here. Okay, so yes, it looks like there are two representations of the number 25. Okay, so this means that the third option is not an option. The fourth option is the correct option that shows repetition. And now we look at if our answer is correct. And it looks like 8 is correct because it turned green.